Welcome to this Taz Academy HVAC training video. Today's topic, up your game. Measure more than gas pressure with your manometer. Add static pressure and vacuum with the UEi SPAK1 Static Pressure Accessory Kit. I'm your host, Total Air Supply Technical Trainer, Randall Ripley. All techs should know how to measure and verify static pressure, vacuum switch pressure, and gas pressure. All three are measured in inches of water column, a unit of pressure mainly used in North America to measure small differences in pressure. In the HVACR world, if you're not testing, you're guessing. Starting up or servicing HVAC equipment can require the HVACR technician to conduct many different tests on the equipment and have the need to buy several different test devices that can get expensive. The UEi SPAK1 Static Pressure Accessory Kit and Your Manometer single or dual port is an inexpensive way to add static pressure and vacuum pressure testing to your skills box. You go from setting and adjusting gas pressure to measuring static and vacuum pressure with it. Here you see the kit. This just shows the kit, and it shows you that you get two pressure tips. They're not pitot tubes, they're pressure tips. You get your T, some hosing, and the case. In a nutshell, the gas pressure on furnaces should always be checked and adjusted if necessary. Overfiring the furnace and or lack of airflow over the heat exchanger are the main reasons for heat exchanger failure. Static pressure is a force that is pushing outward or pulling inward in all directions on the duct system. The walls of this ball are the resistance to the air pressure and will not allow it to go any further. The pressure inside the ball will then exert itself equally in all directions, allowing the ball to hold its shape. Pressure tips, not pitot tubes. Holes on the sides are for measuring static pressure, aka resistance. No hole on end of pressure tip for measuring velocity. A pitot tube does have that. As you see here, pitot tubes have that, the openings on the side, the pressure, static pressure measurement, and one on the front, velocity pressure measurement. Pitot tubes consist of two tubes, an inner pitot tube and an outer static tube. When we measure static pressure, we are measuring the total external static pressure, which is a measurement of all pressure drops external to the unit, or in other words, outside this box. This is what we are trying to measure. All pressure drops within the unit, like the secondary and primary heat exchanger, are not included because they have been accounted for in the design of the air handler or furnace and are not external to the air handler or furnace. Pressure drop is the loss in pressure created by any component of the system that creates a loss of pressure as the air flows through or over it. The centrifugal fan in the furnace blows the air straight up and therefore does not cause a pressure drop. Filters, coils, heat exchangers, registers, grills, and balancing dampers are some of the pressure drops you can have in your system. Before starting total external static pressure test, make sure that all the duct dampers and registers are fully open. Check for dirty air filter. Tests must be done with a clean filter. Open all interior doors in the space the equipment is conditioning, especially in rooms that don't have returns but have doors that close, because a door that's closed on a room that doesn't have a return inside that room is basically acting like a damper and not allowing that room's airflow to circulate in the system. You can use the hole on the side for the low voltage wire if it is not being used, or drill a hole in the blower door. This will not void your warranty to get the pressure reading at the blower inlet. But on these two examples, the one on the left, the furnace, you notice that the tip of the pressure tip is pointing into the airflow, meaning that the airflow is going in the opposite direction of the tip. And that you want to make sure that you get as best you can. Sometimes there's some weird applications and you might not get it as perfectly into the air direction, but try to. And as you can see here, it shows you that we're under the A coil and inside the cabinet, inside the filter. And that's where you always want to be, because again, remember, we're trying to measure the external static pressure, which means everything external to that furnace box. And on the right, we see an air handler, and it's done the same way. You notice in this one, we're pointing down, and the airflow is actually coming in and then going up. But in this case, it wouldn't be turning it very well. But anyway, that is that's a valid measurement for an air handler. Just always remember, you need to be inside that all external pressure drops. That's the most important part of it. Testing with a single port manometer. Measure the static pressure on the supply and record the reading. Then measure the static pressure on the return side and record the reading. And just remember, it doesn't matter which one you measure first. You just got to measure both. Don't pay any attention to the fact the supply is a positive number and the return is a negative number. Just discard the plus and minus and add them together, and that is your total external static pressure number. So we see here that we have a supply of 0.2, a return of 0.41, and a 0.64 total external static pressure. Your total external static pressure is a little high, which could be caused by a lack of return air grills, undersized ductwork, that kind of thing. And the advantage of testing with a single port manometer is you already have each individual reading and know which side is causing the problem. If we only had a reading from a dual port manometer, you would need to go back and test each one individually to see which one is the problem. But 99.9% of the time, it is the return. And the reason for that is cost engineering. Nobody, goes around saying they're not going to put returns in a room. I mean, supplies in a room, but they certainly will go with as few returns as possible, and then they get undersized or duct sizing. But anyway, that's a little high. Now that we have a static pressure number, let's find out what our airflow is. The unit is rated for 0.5 inches of water column. The rating is on the nameplate. 400 CFM per ton of airflow for conventional AC equipment. And we're just talking AC here. I realize that we're talking about a furnace, but it would be the same as you'll see here in a minute in the chart. With your external static pressure number of 64, plus your fan performance chart, you can get the CFM. And the fan performance chart is in the spec sheets now. It's in the installation manuals of the equipment. If we look here, we find our fan performance chart. We look at the number of, get our model number, and we look at our chart, and we're in a 0.64 static. So right now in high, we would have 1,194 CFM for 3-ton unit. And if you notice on each column up to the 0.5 static limit, it has the rise as well. So, you can see that, whatever airflow, you look at your temp rise and you'd be able to find out what, CFM you would need to keep that temp rise. So we're over a little bit, but we know to stay at a 59-degree temp rise, we need 674 CFM on low speed. At the 0.64, we would need 600. We'd only be getting 620. We can get 817 though at medium low, and so on and so forth. And then you just have to interpolate a little bit what those rises would be with a little more or a little less airflow. Checking inducer vacuum on pressure switch. If you are having trouble with your pressure switches not closing or opening during the heating cycle, use your single or dual port manometer, negative pressure only on the dual port, and the T in the UEi SPAK1 kit to measure inducer created vacuum. And as you can see, this is how we would hook this up. It's just and that little T is very helpful with that. Putting your manometer in line with the pressure switch allows you to monitor and measure the vacuum being created by the inducer motor. Common pressure switch access port there, because that access port's actually for both. It's common to both the low fire and the high fire. And draft inducer vacuum port in the back. And as we can see, we're teeing off, so we get the pressure reading there also. The amount of vacuum needed to close the vacuum pressure switches must be greater than the number on the switch nameplate. The vacuum reading should be 10 to 20% more than the vacuum requirement listed on the pressure switch. And that, some can be even a lot more, but you should have at least 10 to 20%. The front cover pressure switch will have the lowest vacuum requirement, and usually that's on Goodman and Manor equipment, it's a 0.10, negative 0.10. The first stage pressure switch will have a vacuum requirement higher than the front cover pressure switch. The second stage pressure switch on 2-stage furnaces only will have the highest vacuum requirement. On a single stage furnace, the draft inducer runs at one speed, and the vacuum should be, and I put 20 to 30% here. I forgot to correct it, but it can be 30% more. Just all depends. More vacuum than needed to pull in the ignition pressure switch. First stage pressure switch and the second stage pressure switch are marked there. On 2-stage furnaces, the inducer will run at a lower speed on a call for first stage only. The vacuum could be enough to pull in the first stage switch, but not enough to pull in the second stage switch. If the unit calls for the second stage, then the inducer ramps up and provides enough vacuum to close the second stage switch. Measuring the vacuum at the front cover, if for some reason you wanted to check that, just most of the front cover switches, as I said, they're negative 0.10 rated. Front cover pressure switch connects on the front cover of the secondary heat exchanger. And as you see, that little nipple for your manometer, for your pressure switch port, is very close to the drain, to a low corner drain. This will show you if the vacuum at the front cover is dropping. This can cause the gas valve to shut the burner down and go through a reignition cycle. Many front cover pressure switch problems are caused by a slower plug drain that is right next to it, causing water buildup and partially plugging the vacuum hose port. Of course, we cannot show you all about static pressure measurements, vacuum pressure testing, the problems and fixes in this short video. You will have to do some further studying on these topics, and we will be doing some, soon we will start doing some courses and putting them online, and we'll go into much greater detail on the topics. And it will be like series of videos, and I'll make them 10, 15 minutes each, but actually it'll be a total of like a 2-hour class, a 1-hour class, depending on the topic. If you like this video, please hit the like button. If you want to see more of our videos, hit the subscribe button so you can get notified each time a new video drops. Thanks for watching. If you have an idea for a video, please send it, including your phone number, to my email address on the screen. You can watch all Taz Academy videos at our YouTube channel. And this is my email address that you can send in any ideas you may have. Thanks again for watching, and hopefully you'll come back for more.